Hi, everybody. So we're just about ready to start with Andrija Panić's successfully running enterprise workloads with Cloudstack and KVM with primary storage. He's been involved in the Cloudstack community for quite a while now, in doing a lot of talking on the mailing list and kind of keeping up with what's going on. And I've really been working now for maybe a year or two with Andrija, and we've had a great time kind of integrating additional features into Cloudstack's primary storage, managed primary storage specifically. So he's here today to kind of give us an overview of how it's implemented at his company, HIAG. There you go.
Yeah, hi everyone, thanks for joining me. My name is Andrija Panić, as Mike already introduced me. I work for HIAG Data. I will kind of spend 1 minute of your time just to briefly introduce the company I work for, and then we'll move to more interesting things, I guess. As I mentioned, I work for HIAG Data, and HIAG Data is basically an anchor shareholder of HIAG. I like to think of that like a daughter company. And HIAG was actually founded over 120 years ago. They originally started in the lumber or wood industry. Times changed, they moved into real estates, and that's the actually interesting point, because later after they decided to move to more obviously modern stuff like IT, because of the previous real estate period, they acquired a huge amount of physical properties all around Switzerland, which are all owned by HIAG. This way, basically, we are able to, what we did actually is that there is completely 100% private network of fiber optics across whole Switzerland, so it's not leased from telecom providers. It's absolutely owned by HIAG, and thus we are able to obviously offer some guarantees on latency, on bandwidth, and so on and so forth. We are also certified to let's say, most recent, including some financial FINMA standard, the famous GDPR and different ISO stuff, and we are connected to a few of edge locations, as you can see, which I will mention later, to actually do some special friendships with big cloud provider guys. So basically, because of the fiber optics network center, we are able to connect customer premises to whatever cloud services we offer. We will very soon, I think beginning of the next year, we'll be offering the container stuff. We already do offer REST object storage. We do also offer a few of Microsoft flavored cloud services, beside obviously Cloudstack that we are running, and a very special private connection and private peering with Microsoft Azure and Office 365s. So basically the users can, from their remote locations, via fiber optic networks, via our data centers, again via fiber optic networks, access some of the public cloud providers, as I mentioned, Azure and Office 365. And actually we do provide guaranteed latency. That's something that per my knowledge and what I have been told from the colleagues in my company, no other actually provider can offer at the moment, because usually you publicly access over internet, there is no guarantees on latency. Enough, I guess, on the company side and the history, so let's move to the actual story. So basically we started our Cloudstack journey, let's say beginning of 2013, and in the early days, basically, actually I should mention we are, as Mike pointed out, running purely KVM. We started with Cloudstack 4.3, we are now running the 4.8 release with a lot of backported stuff, obviously. And we did start with that Ceph as a storage solution for us because of some great properties it has. I guess you can all read, I don't need to repeat every sentence, but it absolutely does provide some of the really nice things. Later we actually wanted a bit more performance and maybe a little bit better integration into Cloudstack, so we went with a NFS solution, kind of a hybrid one, and this was do-it-yourself solution, which is important. I will mention later why. Then we moved to a fully SSD NFS solution. Again, there are some limitations for that. Obviously not a good quality of service or not true quality of service with this, and that's basically where we were. During this original period, we did kind of face a lot of different challenges, which is a nice way to say a lot of issues that not many people or too many vendors will actually share with you. We do share because we believe that's a nice way to actually learn and maybe save some people some trouble at least. So we can basically, let's say, filter these issues in a couple of categories, which is stability, performance, and maybe usability/management. I do need to mention that we started our CEF journey very early, and most of the issues are actually fixed so far. So if you are now to start with using and consuming CEF as the primary storage, it's much better situation. Performance-wise, your thing will vary depending on your setup, how much you invest in hardware and so on, and usability and management stuff. Some things have been fixed or improved, and some things are still a challenge to be solved. So let's dive into a couple of concrete, let's say, original issues. Basically, in the very early stage of using CEF, there was obviously some unhandled stuff and simply things that weren't accounted for, and basically any kind of exception in librd, which is RBD client library for libvirt to communicate with the CEF cluster. Any kind of exception would basically crash the agent, which means that the VM high availability mechanism would kick in and you get downtime. A couple of examples are given on the slides, but I do need to mention this is mostly solved in the meantime. So you will not experience the same thing we did if you start now. Now also CEF rebalancing and deep scrubs basically can impact client I/O heavily, up to the point if you don't have let's say most properly sized hardware. If you do some other let's say slight misconfigurations or maybe lack of a bit of optimization, then you can get to the point where the client I/O is basically not served within 30 seconds or so, and then a more sensitive file system will get to read-only mode, and you can imagine client's joy. Then also flapping, which is actually an official word for some services going up and down of the CEF monitors and OSDs, which could happen due to network issues, not because of CEF itself. They can also cause what I mentioned, slow requests, and basically the I/O was not served to the client in appropriate time. Then also, when we speak about stability, volume snapshot says they're running up to at least 4.11 release. As you know, the snapshots are taken on primary storage, and it's then being copied over to secondary storage. And this can actually take often long time to complete, and then it can actually block other job queue for the other items in the KVM agent. I believe, maybe I will be wrong, the guys from Schubert Phillies or somebody else actually originally documented this issue. But basically, you will not be able, for example, to start a VM or to start a virtual router because there is snapshot running. Sounds kind of silly, but it can happen in very specific cases, but it did happen to us a couple of times. Also, as I mentioned, we originally used the do-it-yourself NFS solution, which was based on ZFS. We once had a kernel panic because of the ZFS module. This is, by the way, my last name with an additional thing. So we got all agents being rebooted actually due to the KVM heartbeat script, which assumes that the storage is highly available and cannot die at all. So it will actually reboot the agent to be able to reconnect. So imagine when the whole cloud in a very early stage is not enough clients to be too stressed, but still it went down. Not nice at all. As I mentioned, now we are, let's say, moving to performance sector. I already mentioned CEF rebalance, deep scrubs or flapping monitors can cause block slow requests. In the previous section, I kind of included instability because some VMs would completely die with a read-only file system. This is now just a performance thing. The way to handle this is actually to throttle a CEF rebalance process, so instead of 1 day, it will take 8 days to rebalance properly, but at least the client I/O is not impacted, and then you are good. At some point in time, we also had serious issues with deep scrubs. I do need to mention that this was hard drive-based CEF cluster with some SSD journals, but we had even disabled the deep scrubs, which is not really a smart thing to do at all. But that's what we have to do in order to survive the slow requests. Also, if you have a faulty network cable from experience, firmware switch from experience, or a failing or, let's say, problematic hard drive, make sure to be ready to fix these issues on time. Otherwise, you will get the flapping OSDs and monitors and things really go to hell in an almost literal way. So this is not issue of CEF. This is issue of the networking, which can be, obviously, has too many moving parts in some way. Also, back in the days, I believe it's still the case in the librados, which is basically communicating to the CEF cluster. in general, there is on the Ceph client side libraries, there is a way to define a stripe size. So for example, if you write 4 megabytes of data to the Ceph cluster, you could theoretically instruct Ceph cluster to stripe the data with a stripe size of, for example, 1 megabyte, and theoretically you would be writing to 4 different hard drives and thus improving the performance. But in Librados, there is still on a Ceph tracker ticket, I would say, there was still no response, and it's not still implemented in the Librados, which is basically, let's say, part of libvirt in that sense, or being consumed by libvirt and librd. So there is no way to actually maybe do some performance improvements. This is not penalty, but it's lack of possibility to improve. Now also I put it in performance section, but I will mention it later. At the early days of us using Ceph, there was actually missing, let's call it a proper snapshot life cycle. So basically, you create a snapshot, you delete the snapshot. It's deleted from secondary storage, excellent. It's deleted from database or marked as deleted, excellent. But it's not deleted from the Ceph cluster itself. And then you can imagine guys having daily snapshots, 24 hours, so that's 24 snapshots a day times a couple of days. You end up with having 50 or 100 snapshots, which I will explain later, during to certain things can actually cause the whole Ceph cluster to really perform really bad. And we did kind of even disable hourly snapshots in the GUI. We hidden the button, not too smart, but less short thing. And then we later did actually implement the Ceph proper removal, snapshot removal code, or the life cycle thing, which was committed, and this was one of our humble contributions. I believe also guys from Schubert Phillips or the Cloud CA, some of these guys also actually did the same thing, so it should be there in the upstream from a long time ago. Then continue with performance, whatever kind of shared environment you use, networking, storage, doesn't matter. If you don't have a proper quality of service with a guaranteed, let's say, minimum of some whatever bandwidth or something, then sooner or later you're going to obviously experience noisy neighborhood. Nothing new there, right? With KVM, I'm now speaking specifically about KVM. There is a way in the disk offering stuff to define a hypervisor quality of service, which basically will just instruct KVM to implement read or write throttling either in bytes per second or IOs per second, irrelevant of the IO size. So this is not really a true quality of service, at least from my point of view. It's more of a, as I said, damage control of a kind. And also, for some reason, it's not applied to hot plugged volumes. You can imagine client spinning a VM, let me touch 10 drives, let me do some benchmarking how their cloud works, there is no throttling, and then he basically will, let's say, cause performance degradation for all other clients. And now, I put this kind of a theory versus practice exercise, but this is actually also explained in a very nice white paper from Intel Corporation about how to reach 1 million EOPS with Intel SSDs and some other stuff. Imagine you send 100 purely sequential streams to a remote storage. Let's say you do RBD caching on KVM, or doesn't matter, or NFS stuff. It's purely optimized, but basically, yeah, you can argue that any storage can actually excel at the sequential I/O, and that would be true. But because of too many parallel streams at the same time, in the background, this actually in practice becomes 100% random I/O. No matter how you optimize the stuff, eventually when your load is high enough and you have enough of parallel streams of data reading or writing, doesn't matter, it will become fully random I/O. So, this is the reason basically that no magical caching will help. Eventually, it does help until, up to the point where you exhaust the cache and you simply do more workload than the cache can handle. And obviously, you need SSDs. Nothing too smart here, but I believe it's important to just mention. Moving to usability / management, let's say, challenges. I did mention snapshot life cycles with Ceph, but just to understand the pain that we went through, and it was fixed, so now it's all fine. As I mentioned, you could have 50 or 100 snapshots on single volume and multiple that by a couple of volumes, and then due to a certain RBD layering issue, the way it works in Ceph, it would cause tremendous performance problems. These are here actually links to the last slide, where I have URLs to original issues raised by different guys in the community. So on the left side, you can actually read about RB layering stuff. We also implemented some kind of temporary snapshot deletion script and so on, and then a proper fix as already mentioned. Now, at the same time, when we got a bunch of snapshots, we actually had another set of problem that was continuing or basically expanded the previous one. When you want to delete a volume, basically it will try to unprotect all the CEF snapshots, but use those specific variables used in Radish Java library. If you have more than 16 snapshots, it will basically fail, cause exception, and again agent disconnections and again downtime. So a lot of let's say fun back in the days, but this was fixed thanks to Widow, and a big thanks even from this point. So yeah. Then a bit of snapshots in practice. As I mentioned, you already know they are being copied over to secondary storage. And you can imagine we have clients of 2, even 4 terabytes trying to snapshot the volume because it says snapshot. But it's not really snapshot, so yeah, we can discuss it later. Yeah. But basically, in a case where there is a failure of the even manually triggered snapshot, depending on in what state it will fail, it can actually cause a broken snapshot schedule for that particular volume, which is not funny because then you need to dig into database and solve issues, and we will address we'll explain how we actually address this problem later. Then also, from my point of view, you know, these snapshots obviously are copies, backups of the snapshots. You cannot revert back resources. You cannot create new VM from the template which you created from the root volume snapshot, or you can create a new data disk which you created from a data disk snapshot. So you really need to provide to create new resources, theoretically with new IP addresses for the VM and so on. There is no really way to just revert back, which is in my opinion, the whole sense of a true snapshot. Then also some minor things which I will not spend too much time, improper file extension when you download the volume from CEF, or improper volume type, or actually, yeah, volume type in database, which will cause issues down the road. But this was initially locally fixed, and I believe now it's all also fixed in the upstream. So again, this is all kind of a history, at least from this point of view. Now, a pretty kind of serious and interesting thing is the volume migrations. As you grow as the cloud provider, you will certainly implement different storages, or at least more storages for whatever reason. For KVM, there was no thing such as like online storage migration, like there is for ZenMotion, like there is for Zen, like ZenMotion or vMotion for VMware. Basically, the only thing how you can migrate volumes between CEF and NFS, for example, or 2 NFS boxes, doesn't matter, is by actually doing the offline storage migration, which means that you need to stop the VM, migrate volume with a lot of downtime. Potentially, this can take hours if you are talking about terabyte-sized volumes, and then start the VM. Obviously, the customers are not happy with that solution. Now I do need to mention a very special case. The reason I put it under quote because there is nothing unfortunately special about it, but you can hit these issues. We did. When you have a very busy VM which has a huge amount of RAM memory change rates, that's usually let's say a busy database server as an example from the practice. Basically the migration thread in some circumstances you cannot simply catch up with the amount of RAM memory changes. Now you are maybe wondering how the hell this has anything to do with the storage, because this is only live migration, CPU and let's say memory live migration from one host to another. You will see later when we actually solve other issues, but we get blocked by this one. And basically you are, with this issue, you are blocked to actually just blindly click put host in maintenance mode and do your work on kernel, camel, whatever. We addressed all of these issues. I will explain basically later. The way to reproduce it, I'm not going to read it and spend your time, but you can use the Google Stress Subtest utility. In literally one line, you can produce artificially, with only 1 gigabyte of RAM workload, you can produce artificially busy VM. You can try the live migration. It will absolutely never finish, even on 10 gigabit network. So yeah, you can basically read that and test it if you're interested. And how we actually solve this, or actually what's the way to solve this in theory, is basically to use Camu's newer version of auto-convergence, which is called dynamic. And basically it will dynamically throttle CPUs of the VM more and more and more, up to the point that the CPUs are not able to produce so much RAM memory changes, and then the VM will not be so busy and it can actually finish the migration. So I don't have any interesting squirrels, penguins, and other stuff to be humorous, so I try to do it here in a couple of slides. How do we solve all these challenges? Should we stop expecting high AVE performance or delete QS, or simply forget about snapshots and live migrations? Of course not. You can solve this in different ways. Obviously, there are some improvements being done as from 4.11 release on some of those things and so on. But the way it happened for us is that basically we went with the SolidFire guys, and I will now explain how we addressed each of the problems briefly, and we'll do 2 out of 5 hopefully very interesting demos for you. So just a few words about SolidFire. It's basically the whole logic of SolidFire as a storage is based around quality of service, which is defined by 3 values out of many properties of a volume. It's per volume, minimum IOPS, we'll explain later, maximum IOPS, and burst IOPS. You can read a bit of more details, but I will explain now in a second. So basically, the minimum IOPS is a property of each volume that resides or lives on SolidFire storage, which basically is guaranteed 100% in all normal and in most faulty conditions, including cluster expansion, repair, maintenance, SSD health checks, which are maybe analogy to Ceph deep scrubs and so on, because there is a certain amount of whole cluster I/O reserved for internal operation, and the other part of the I/O pool, in the sense of how many IOs you can offer to clients, is actually reserved for the clients. Also nice thing, but this is actually, you can argue this is true for any storage, SolidFire snapshots stay on SolidFire, and this is how it's implemented in Cloudstack. So creation and restore from snapshot is literally like 2 seconds or 3 seconds from the GUI of Cloudstack. In the backend is probably even more quick. No more block job queues, stability issue solved. No unneeded network traffic and sending data to secondary storage, a bit of throughput issue solved. No basically issues with large number of snapshots because of the way it's implemented internally in SolidFire. And also when you handle any kind of, let's say, new storage, is it Ceph, is it SolidFire, is it any kind of other solutions, you do need to have some management skills. With some storage solution, it really is a challenge to actually solve this all. But with SolidFire, I personally believe 2 business days stretched across multiple occasions and scenarios is enough to actually handle what you need to handle as the client. Everything else is actually done by the, I said SolidFire, which is now NetApp support, including upgrades, expansions, monitoring and alerting. You get a dead power supply. I have no idea that I have that power supply. The guys from NetApp send me an email, Andrija, check power supply cable fine, so power supply dead. We send same day. So I personally had extremely positive experience with SolidFire guys. Not a commercial for them, but you don't actually have with all the vendors. You will actually agree on that. And I actually think of this as a managed storage is in every way, not in a Cloudstack terms, managed storage, but in basically every possible way. And also no external libvirt library, so there is no way to crash that easily libvirt, because it's only iSCSI LUNs that are mounted remotely to the host and then just pass through like a local volumes to the VM. These are a list of some of the improvements that we have actually kind of requested or asked Mike to implement. As I said, this is not a commercial to SolidFire, so you do see that some of, I can say maybe a bit medium basic features were not there. So you could not install VM4 template, you could not download volume from SolidFire and so on. You needed to do some couple of steps. So, it's not all shiny initially, and then we basically asked Mike to help us with this stuff, which we did, and this is now part of the 4.11. We use it in a 4.8, and basically I believe we don't miss any kind of storage feature when you do any kind of storage stuff in Cloudstack. We don't miss anything when we compare it to what we could offer to our clients with NFS and Ceph. So let's move forward. How is basically a snapshot thing, which I already explained, the issue of snapshots not being able to restore, takes forever and so on, how it's solved with SolidFire. And by the way, we internally even renamed this to backups in the GUI, because it's not snapshot, it's really backup. Now we need to revert back. So how we solve this? Basically the way that the SolidFire plugin inside Cloudstack is implemented is that it references snapshots on SolidFire. There is no copying over to secondary storage, so it's fast, it's blazingly fast. These are real snapshots, as I mentioned, because you can easily restore from original VM instance, disks, whatever. Internal thing which you maybe don't care, but there is almost no space consumption, not literally, but almost, and no need to move tons of data across your network, and no block job queues in Cloudstack. So you can start your VM if you want. Now this is a 3-minute demo, which I'm not going to do because I need to kind of save these 3 minutes for other interesting one. It literally takes 3 minutes to make a VM, create important data, create snapshot, cause destruction by deleting the data, and then restore the whole VM or the root volume or whatever you want. It takes literally 3 minutes, so please, you can view it at your own pace. The demos are embedded, and there is also links at the end of the slides, so you can actually view them directly on YouTube if you want. So let's move forward because I need to spend time for a more interesting demo. So quality of service I already mentioned. It's kind of halfway there because you can only limit read and write rates in bytes per second or IO per second, whatever limit you hit first. And one very, very important thing not related to CF, NFS, it's related to any storage. You seriously need to have some voodoo skills to actually understand if your clients are having good performance after 1 year in production. When you load 2 times more clients on the same storage, how the hell do you know if the clients still have good latencies as they had 1 year ago? Because you usually don't have access to clients VM, there is no way to measure this. And basically this is what is another positive benefit actually of SolidFire. And basically we are leveraging quality of service, which I mentioned is the whole, let's say, center of the SolidFire. It was built around quality of service. There is zero possibility for noisy neighborhood. So basically, clients usually get much more what they pay for, which is the maximum IOPS, and in certain cases, burst IOPS, which can give you a burst up to a certain amount of IOPS in a critical times during VM reboots, database dumps, and so on. And it also has a perfect monitoring environment, basically, where you can see if you need more gigabytes, terabytes, or you need more IOPS. So we will do this demo, and I will explain as we go through, but when you maybe view the slides offline, you can read as well. So I have something, yeah, good. The demos are recorded obviously for making sure we don't do any kind of issues. The demos are with sound, it's just now muted. So we have basically demo VM, nothing special. And you can observe actually the volumes of this VM. We have one root volume. It's located on NFS in this example. This was just deployed VM from template. We'll use the virtual dump XML with grabbing the IOTunes section. You can actually see that it read bytes, write bytes, nicely implemented IOTunes section. And inside VM, for some reason, I decided to show you we have one volume. Now I will actually, what I will do, and you can trust me on this, I will actually attach one NFS data volume, one CEF data volume, and one SolidFire data volume. And yeah, and let me just verify this so you can actually see. We have root, one NFS, one SolidFire, and one CEF volume. The SolidFire is the last one, just for the reference later. If we go back to the actually inside the VM you see 3 new volumes are attached, VDB, VDC, VDD, whatever. And if you go back to the host, physical KVM host, if you repeat the same dump XML command, you still see iTunes section for root volume, no iTunes section for VDB, which is NFS, VDD, CEF, and VDE, which is SolidFire, but that's fine for the last one at least. So there is no iTunes section either, though we use the disk offerings which do specify. So let's stop and start the VM so it will actually pick up properly the thing. In the meantime, I'm just briefly showing you SolidFire GUI. This is our quality of service volume, as we called it. There is minimum IOPS, maximum IOPS, and burst types, which is multiplier. Let's say 2 times, that's 4,000 of the maximum IOPS. And basically, that's how quality of service is done on SolidFire. It's done on the storage side, not on the hypervisor side. If we start the VM, basically, we will very briefly be able to see a proper KVM quality of service implemented for NFS data disk, CEF data disk. So basically, I will open here a new tab and copy over the same command of virtual.xml, then grabbing interesting sections. And now if you repeat the same virtual.xml, we see IOTune on root volume, IOTune section, which is KVM way to implement throttling on NFS, on Ceph, and still no IOTune section for SolidFire because it shouldn't be there, it's on storage side. And just to basically now, that's pretty much it on the KVM level. For some reason I decided to show, I'm not sure why, that we still have 4 volumes inside the VM. But if you go actually to show you how is this differently implemented, hypervisor quality of service or storage quality of service, let's go to actually this conference and let's actually see, I almost fall down, Mike. So some regular parameters, name, description, size, and so on, nothing special there. But the interesting field is quality of service type. If you choose hypervisor, you see here disk read rate, disk write rate in bytes, and same for in IOPS per second, different volumes. This will be passed to the KVM when it generates the XML definition file, and that's how you actually generate quality of service on the KVM side. If we choose storage quality of service, we have minimum and maximum IOPS, and these values will be used by SolidFire plugin. It will be passed to the backend SolidFire cluster, and it will be created. It will become the properties of the freshly created volume, minimum, maximum. You don't see here burst because burst is basically hard-coded, so to speak, but you can change it in database, multiplier of the maximum volume, maximum IOPS. Whatever is the maximum IOPS, you can say burst is 5 times more because it can only burst for 1 minute or 2. So that's basically the differences of quality of service on KVM and sorry, just a second. Yeah. So you spend a lot of money, and you have a nice SolidFire cluster, you know, and you change all your disk offerings and compute offerings to actually deploy new resources on the SolidFire. That's perfect. But you have probably tens of hundreds of volumes, and how that are left on Ceph or NFS or whatever kind of storage. How do you actually migrate this? One way, which was freshly implemented, is offline storage migration, but it's really not logistically possible due to negotiations. It's simply not possible. Then we become greedy and we ask Mike, can you please implement online storage migration? This is, as I mentioned, new in 4.11. We're using it bed ported. Please pay attention to the extremely nasty bug. I'll read it when you have time, because if you don't handle it, it will limit your migration speed to 1.3 megabytes, and then you will say, why SolidFire is so slow? It has nothing to do with SolidFire, it's a libvirt bug. Now, how this works, actually, this works, we will see this in a demo later, but basically volumes of the VMs, of the VM which is, for example, existing on NFS, are mirrored on a block level, they're mirrored to automatically provision volumes on SolidFire, and then at 99% when it's done, the KVM will decide it will kick in the VM live migration, which is CPU and RAM memory, basically, or the RAM memory content of the RAM memory from the source host to the destination host. But this is now the special case, which I mentioned previously. You migrate terabytes of volumes potentially, and then KVM says, yeah, finally, let's live migrate the VM, and then you are stuck because the VM is busy. It's a database SQL server. So the way we solve this is, again, thanks to Mike, actually, we implemented, or Mike implemented, being able to consume dynamic auto-convergence by obviously a code and a single global parameter. And basically, this is available only in KEMU 2.5 and newer by default. It's kind of, let's say, intelligent throttling, so the way it's dynamic, it throttles more and more and more, up to the point it actually works. But there is also regular auto-convergence from KEMU 1.6 and newer, which is useless, believe me. Here we have 2 demos which we're going to skip, and I will explain them. The first is just showing the dynamic auto-convergence versus extremely busy VM fight. So basically we are using, again, the stress subtest utility. We are writing to 59 gigabytes of RAM with 24 CPUs. I'm not sure that any database server, not literally any, but not many get that busy, but this is extreme of the extreme. And then you will observe, with VirtTop utility, we observe the CPU utilization on the host. It's single VM on a single host, so you can see it very easily, and you can then read it on your own pace. I'm going to do a super demo of this one, and the demo of the online storage migration. This one is a perfect world demo of idle VM doing nothing, which is not what you have in production, and how you migrate NFS and Ceph volumes example to SolidFire. This is a new API call with 4.11 release. Basically, you need to specify the virtual machine, the API call, of course, yes, but then you need to specify virtual machine ID, or which volumes you are migrating. Since we are doing also the live migration of the VM in the end, we also need to specify destination host. And of course, we have pairs of destination pool and a source volume, destination pool and a source volume. So basically, this is SolidFire UID or ID from the GUI, and NFS ID again of the source volume which you want to migrate. We repeat same pair of let's say variables for Ceph. So it's very easy. It's only kind of 5 minutes, and you can do it at your own pace. And basically, now I'm going to do a super demo, which is, I guess, something you actually don't see that regularly, and it's kind of almost crazy scientist. So we will cause the busy VM by writing with 24 CPUs using the stress subtest utility. We are going to write to 60 gigabytes of RAM. It's basically just scoping over RAM memory pages. You can believe me, you can see at your own with over 12 gigabytes per second copy speed inside the VM. And you can imagine if this is throttled enough, then it really works. At the same time, we are touching 2 NFS volumes, which we're going to explain during the demo. We'll do the FIO benchmark, writing heavily to the source volume, and then try to do online migration of the source volume, which are heavily stressed, to the SolidFire. I will explain during the demo, so you don't need to actually read everything. This is a fancy branding that I did just for this demo of the GUI. Completely amateur, but let's log into our fancy branded environment. And we have a VM which we're interested in. Click. You will actually see that this VM is with the offering of 24 CPUs on SolidFire. Here you see actually 24 CPUs. It exists on certain physical hosts. We will see that later during the demo. If you check the volume of this VM, we see one root volume, which is actually on SolidFire. We don't care about this one, forget it that I ever mentioned it, but just for the reference, this one is already on SolidFire. But we have 2 old volumes, you can imagine, of 100 gigabytes using NFS offerings existing on certain NFS storage, 1 volume, 2 volumes. And basically, we'll do a software RAID inside the VM, which you will see RAID 0 actually on top of 2 data volumes, so we can actually write in parallel and stress them in parallel in a serious way. So yeah, source host. We have a VM running, obviously with wish list, nothing special. It says core source host. As I mentioned, the sound exists with the demo, so I basically repeat myself as well. On the destination, sorry, I don't maybe pass. Again, on the source host, we are using the virtual DOM job info, which is a way to observe the live migration, not online migration, just the VM live migration process. And we're also using the virtual block job info on 2 source volumes, both NFS. Are there any block level jobs, which actually means online storage migration? Is it started or not? Not for now. Nothing is started for now. We'll use stress up utility to 59.5 gigabyte of RAM. We'll leave kind of 500 for the operating system to breathe, with certain parameters for the stuff. We have the root volume. We have 2 data volumes of 100 gigs. We have VDB, VDC, whatever, and we have software RAID 0 on top of this. If you check, you see actually almost 200 gigabyte formatted file system with X4. And we are using a FIO utility, which you are all familiar with, to actually write a 100 gigabyte file across 200 gigabyte volumes. This is dev environment, so I'm limiting the write rate to 150 megabytes, but you will agree it's huge amount of megabytes per second. 0 CPU utilization, IOStat, 0 disk utilization, nothing. So let's now make a busy VM really busy. Let's start the, let's say, torture test, so to speak. This takes a couple of seconds to actually really build up, 5 to 10 seconds, not more. Let's also hit the FIO. We are limited to 150 megabytes. You can see here, it actually does as much. And after a few seconds of the stress up utility running, you will observe the CPUs, they are literally 100%, all of them are actually being used to copy memory inside the VM with a huge migration rate. Source, we use the very top utility. We see the CPU percentages on a source host, which we are stressing the VM around 75%, which is 24 CPUs out of 32 physical on the host. And this will get down and down and down and down as the CAMU dynamic autocontrol just later kicks in. So let's start the Cloud Monkey. Let's basically issue our API call to try to migrate, online migrate this VM from NFS to SolidFire. We have API call, virtual machine ID, host ID, and then as I mentioned, migrate.0, which is, and then pool, which is SolidFire pool destination, source volume on NFS1, again, SolidFire pool destination, the second volume ID. So we can hit enter and just wait for 2-3 seconds, so it really actually starts on the, let's say, physical level, on the storage and hypervisor. Just a few seconds, it will start. Now it's still not actually started to do line migration, it's preparing, but here you see a block level job copy process. This is the mirroring of two NFS 100 gigs to automatically provision two times 100 gig on SolidFire. You will see that shortly. On destination host, we see the same name of the VM, but in a paused state. This VM has identical XML definition file as the source VM. It's paused, but it's not really identical. It's referencing SolidFire volumes now, not NFS. This is a nice SolidFire GUI. These top two are the two 100 gig volumes which we automatically provision by issuing the API call. I will basically briefly just increase the maximum IOPS to 25,000, so actually this makes sense, and I will repeat this. I will repeat this for the second volume as well. So you see minimum, maximum, and you can override the burst IOPS for the single volume. This is how you change quality of service, manually of course, but you use it through the Cloudstack in a normal way. If you observe the reporting tab and volume performance, you can see volume performance per volume, which is not something you can see very easily on different storage solutions. It takes a couple of seconds to actually build up the throughput and so on. But basically I will now try to do a kind of a split window view between the migration process of the volumes as seen from the hypervisor side on the KVM and the actual SolidFire, and then I will rewind this so we don't need to spend 46 minutes for the demo, of course. So let me rewind this. As the time goes by, you can see the write rates on the two freshly provisioned SolidFire volumes, which will be which are replacement for two NFS volumes. If you rewind even more, you see they are basically written with 200 megabytes. And so on, so on, so on. I will just, I paused this video many times, obviously, because it took 1.5 hours to actually do something. The volume migration process is still going on. In the slides, I already wrote interesting times, and I happen to obviously know it's on 27 minutes, and so let's rewind. 27 minutes and 35 seconds or so. You can observe the volume copy progress, which goes up and up slowly. Very slowly, actually, but it does. And let me just rewind this. Oops, I did it too much, sorry. So, 99% of the volumes are mirrored, not finished yet, and any kind of additional changes are still being dynamically mirrored to the destination. At some point, about just now, the KVM will decide, okay, I have mirrored enough of storage, excellent. Let's now kick in the live migration. And basically, this is where the RAM content of the memory is being copied over to the destination host. You can see a bandwidth rate of almost half a gigabyte per second. This is over 10G network. You can see iterations, which is let's say, important and interesting way. This first migration, after all, 59 gigabytes are migrated. As you can see, data processed and data remaining. After it migrates all the 59 gigabytes, the KVM will say, okay, I migrated whole RAM memory. Let's check what has changed since I copied this whole 59 megabyte, and it will say, oh crap, somebody's stressing the VM, everything changed. I need to copy again all 59 gigabytes. And then basically, this is where KVM will start intelligently thinking, let me throttle the CPU more and more and more. You can actually see, after this is kind of finished and goes into second iteration, you can see dirty rate, the amount of memory pages of second, which is calculated in a second run from the first run. Not too much important, but you could observe this going down. So if we rewind this a lot, you see it's now in third iteration. You see now it's 11th iteration. You see now it's, I don't know, in whatever iteration, in 13. So it failed like 13 times. That Kemu is, every time is throttling CPUs more and more and more up to the point, come on, man, down, down, down. And basically, very soon, it will, I believe it took around, well, that's not what I wanted to do. But here we go. Basically, it took around 20-something iterations to really completely throttle enough the CPUs and lower the page rate, which is kind of not very indicative, if you see. But you can see actually it already moved kind of 600 gigabytes of data of RAM memory content was moved, although the RAM memory is only 60 gigabytes. So it's repeating this again and again and again. And then at some point we have only, it's finished. Yeah. It's completed, and a second later the command will say no such VM, because the source VM has been migrated. It's destroyed on the source host. It's again running on the destination host, which I kind of failed to prove or to show you, but that's pretty much it for the demo. Here you actually have a couple of interesting links, which is our own, let's say, commit, RB layering issue, which I mentioned, Windows fix for Rados Java, executing sequence where you cannot start the VM because snapshot is running. Also, you have a few of direct links to the demos. These are at the moment on my personal account, but they will be moved to a company HIAG account soon. I will try to make sure these are valid for some time. And then you have a couple of other links, excellent videos from Mike, obviously, on different stuff related to SolidFire and Cloudstack. A few of live migration geek, low-level details, also what to expect with Ceph. From Mirantis, they actually know what they're doing with Ceph. And also some other Ceph architecture, for example, from Red Hat if you want, and so on. And we have a small, like I said, kind of a bonus, which is an online migration script from HIAG. We had to migrate a bunch of VMs from NFS and Ceph to SolidFire, so basically we just feed a simple JSON file to the Jenkins job, which consumes the script. It just takes the UID of the VM. It will dynamically find out in a certain way if volumes are existing, what volumes are not on SolidFire, and it will generate the proper API call and shoot it to the management server, and it will basically migrate the VM. You do need to pay attention if you're using different tags on these offerings after you migrate. You might need, like we had, because we have different storage tags on Ceph and NFS deprecated, and we have SolidFire tag on a SolidFire stuff. So depending on your usage of tags and storage and offerings, you might need to ask for the client, please stop the VM, change the offering to us, the current SolidFire one, start the VM. So that's like 30 seconds or 1 minute, let's say, of downtime. So that would be all, I guess. If you have any questions, I'm happy to answer. Please.
So the online storage migration feature does not work for migrating from NFS to Ceph?
Mike, I believe the colleague asked if the online storage migration is working for NFS to Ceph or the other way. And yeah. Yeah, but it's a great improvement. There is no actually magic there. It's just being missing in Cloudstack world, because this is, you can do this manually by which migrate whatever the command dash copy all storage. That's the basic command. Then you define the remote host and so on. If you feed the XML, we just changed volume references, so it doesn't reference NFS, it references SolidFire, or it references Ceph, for example. So you could manually just issue the migration job, let's say, and this has been now very nicely implemented by Mike. I believe that there was, in certain cases, we had this kind of scenario because of tags and everything. There is certain cases where the migration from Ceph to SolidFire will maybe not work, again, if you are using tags in a certain way. And this is from 4.11.0, but it has been fixed in 4.11.1 or 2. So it has been fixed now in the most recent, let's say, update release, so to speak. Yeah. That's all. Okay, thank you.